This video is on Unit 13, Lessons 3 and 4. It is only one page in your flip book. They are on the same page. You might have to flip past 3.5 to find it because I needed more room, so I put it later in the flip book. And this one is mostly on normal distributions and z-scores. So before we begin, this curve right here, you may have heard it called the bell curve before. It is also called the normal curve in statistics. And it just tells you basically if data follows the normal distribution, this is how it would be spread out. Now you'll notice 0, that is where you would put the average or the mean. So right there is where the average would go for that data at 0, right in the middle of the curve. It should make sense. The average would be right in the middle. And then you'll notice these numbers down here. That tells you the standard deviations, how many standard deviations you are away from the average. Remember, if you were 1 standard deviation away, you could be 1 above or 1 below. So if you were 1 standard deviation from the mean, you would lie in this range here from -1 to 1. If you were 2 standard deviations away, you would lie from -2 to 2, and then so forth, 3 standard deviations away. After 3 standard deviations away, there is usually no data outside of that. If there is, it's maybe only like 1 or 2 data points, depending on what you're measuring and what your data actually is. But it's very, very low chance you'd be less than 3 or more than 3 away from the standard deviation. So, unfortunately, you don't get this curve on your Regents exam. You used to, but you don't anymore. So, the nice part is, though, you can find these percentages on your calculator. So, these are the words you're going to be looking for on your calculator. And to get there, you're going to hit on a calculator screen, Menu, Statistics. You're going to look for distributions, and then you're going to look for the normal CDF. It's right there. I can't remember the numbers that these are in the menus, but once we do it once, then you can write down what numbers to just hit, but those are the words you're looking for. Basically, the lower and the upper are how far, if you're talking about standard deviations, how many standard deviations away you want to be. So for this first example, we will just, I'll do an example on the calculator for you on the screen, and you can just follow along. And then if they actually give you, though, the lower and the upper data points, then you would use those. Like if, for example, if we were talking about scores, if they gave you the lowest score and the highest score, they'd have to give you the average and the standard deviation. You need all 4 of these to type into the calculator, and then the calculator will spit out what percentage of whatever you were talking about, if it were test scores, what percentage fall within that range, depending on what the question was asking. So for the first one, they just want, like, if it's just normally distributed, find the percentage of the population that would lie within 1 standard deviation. So if you go to your calculator, and you go to just a normal calculator screen, so again, if you're at the home screen, just go down here to the calculator button. You're going to hit Menu, Statistics is number 6, Distributions is 5, and then we went Normal CDF, so that's number 2. You need your lower bound, your upper bound. This is another symbol for average. I know we were using the X with the bar over it, but this is another symbol for average, and then this is standard deviation. So if we want to be 1 away from the average, and we don't know what the average is, we just want, like, generally what percentage is 1 standard deviation away from any average. So the lower bound would actually be -1 because we want to go 1 below. Then our upper bound would be 1 away. Our our mean is 0, it's right in the middle, and then our standard deviation is 1. If we hit OK, remember, this isn't as a percent, it's a decimal, so you'd have to convert that to a percent. So just move the decimal 2 spots to the right, or multiply this number by 100. So it's approximately 68.27%. So write that down for the first answer, 68.27%. Now the second part says go within 2 standard deviations. So this time you're going to do menu, statistics, distributions, number 2. We want to go from -2 to 2. Our average is 0, or our mean, and our standard deviation, we're only going by 1. It's about 95.5 or 0.45, depending on how many decimals. It doesn't say what to round to. It will on a test question what decimal to round to. More than 3. Okay, so listen carefully. You might want to make a note to yourself. If you're ever asked to do more than or less than a certain number, your upper or lower limit is going to have to be, you're going to want to use either -10,000 or 10,000 as your upper. So you want to definitely, you won't ever have numbers bigger or smaller than that. So as a general rule of thumb, you just want to use those numbers as your upper or your lower. So if we want to be more than 3 standard deviations away from the mean, you could also do from 3 to, or -3 to 3 and then subtract from 1. But let's do, so we have to do more than 3. So we have to do distributions. We have to do normal CDF. We want to go from 3 to 10,000 and hit OK. There's that percent. So if we go over 2, that's only a 0.135%, but that's on the upper end. Now we have to do for the lower end. So we have to do it again because we have to, it just said more than 3. So we could be like 3 on either end. So statistics, distributions, normal CDF, we could be from -10,000, 1, 2, 3, up to -3. That's also 0.135%. So now if you do 0.135 plus 0.135, that is about a 0.27% for being more or less than 3 away. Or more than 3, sorry, not less than 3. 0.27%. So it was really 0.135 plus 0.135. Okay, now we want to be between 1 and 2, above the mean. So not between 1 and 2, below the mean or above, just strictly above. So we're going to go back to menu, go to stats, go to distribution, go to normal CDF. We want to be between 1 and 2. Hit OK. It's that percentage. Well, that's a decimal. Move it 2 spots. So it's about 13.59%. So next to letter D, write 13.59%. So that is it for that question. Now there was actually kind of no data there. There wasn't like we didn't do a study or anything. We just said, generally speaking, if it follows the bell curve, what percentage of the score should be within those parameters. Well, now we're actually going to do a problem with actual data. Now there is part of this question missing. The part of the question that was missing was actually setting up what these numbers represent. These are SAT scores. So we're going to say that the mean or the average of SAT scores was 540. The standard deviation is 80. Find the percentage of the population that lies in the following, and let's make a little note to ourselves. We were missing the beginning. It was out of 424 juniors that took the SAT. So it should have started with that. The question should have said there were 424 juniors that took the SAT. The mean was 540, the standard deviation was 80. Find the following percentages. So now, this time when you go to your calculator, you are going to, this will come up, there it is. Okay, menu, and let me pull this aside. It was 540 and 80. So you're going to go to statistics, distributions, normal CDF. Our lower bound, we want to know, we want to be between 500 and 660. So our lower bound is 500. Our upper bound is 660. Our mean was 540, and our standard, whoops, take away that 0, 540, and our standard deviation was 80. Enter. Okay. The percentage would be 62.47%. So you would write that down for letter A, 62.47%. Now, more than 740. So we have to be our lower bound. So go back to menu stats, distributions, normal CDF. Our lower bound is 740. We want to be more than that. Well, like I said, if you want to be more or less than something, either make your upper limit 10,000, or if it's less than, you want to make your lower limit negative 10,000. So we're going to make it 10,000. The average again was 540. The standard deviation was 80. And your calculator will tell you, move this 2 spots, it's 0.621%. So very low percentage, 0.621%. Now, knowing those percentages, you can answer the next part of that question. It says, well, how many kids then actually did score between 500 and 660? Not what percentage, but how many actual kids got a score between those two numbers. So all you're going to do is take, well, we had 424 students take it, times the percentage. Now remember, you don't actually ever use the percentage when you're doing algebra. You got to move it back to be a decimal or put it over 100. It's 0.6247. That turns out to be 264.9 students. Well, you're going to round that up. It's approximately 265 students got between a 500 and a 660. Now, when they want more than 740, we know that 0.621% out of 424 scored that. Oops, I forgot to move it. Remember, we don't actually use the decimal or the percentage. We have to convert it back to a decimal. So either put it over 100 or move it 2 spots back to the left. So I need 0.00621, and that is 2.63, which is approximately 3 students. So not very many, and that should make sense because it's only a 0.6% chance that you would get over a 740 on the SAT for the math part. I believe that was only for the math part. All right, the next and last part, this goes with lesson 4. It's the Z-score. Now, let me explain what the Z-score is measuring really quickly, and I'm going to write down here. Hopefully you have room somewhere on this page to write this. The Z-score, what it is measuring is how many standard deviations, that particular data point is away from the mean. So write this down. And you need to know, so the formula up there has the symbols, and you just need to know what those stand for. So the X is your data point. Okay, so the X is the data point. This is your mean, and then this is your standard deviation. So the Z-score just tells you how many standard deviations away that your data point is from the average. So in this example, they tell you the average is 62. They tell you there's a standard deviation of 3.2. They want to know, well, if your height was 66 inches, how many standard deviations are you away from the average, which could then tell you the percentage if you then used your calculator to see what percentage of people are within that range as well. So we are going, you got to make sure, oh, I got to add something else down here. If you get a positive Z-score, that means you are above the mean. And if you get a negative Z-score, that means you're below the mean. So do not change the order. Don't freak out if you get a negative number. So don't change the order. It always has to be your data minus the mean. Don't ever change it to be the mean minus your data point, okay? Because you want to know if you're above or below, like which way on that curve do you fall? Do you fall to the right or the left? So you have to do your data minus the mean. So my data in this one is 66 minus the mean is 62 divided by the standard deviation, which is 3.2. That turns out to be 1.25. So you are 1 1/4 standard deviations away from the mean. So you could then use your chart to kind of analyze that and look at the percentage of scores that actually fall within that range, 1.25 away. Letter B, you'll notice 57 is less than the mean. So this is where you're going to get a negative z-score. So that's going to tell you you're actually below the mean, so you would fall to the left. So again, you have to do the data point minus the average divided by the standard deviation. That turns out to be negative, well, I'm not going to have room here. There's a couple decimals here, 4 decimals. Negative 1.5625. Okay, so the negative tells me that I'm below, and I'm 1.5625 standard deviations to the left of the average. And that is it for lessons 3 and 4.